The topic of the week: equilibrium of a rigid body under the action of a coplanar force system. Let us start with the definition. A coplanar force system is such system of forces which lines of action lie in a common plane. We are to deal with such system of forces as we analyze a variety of engineering systems, building structures, and household appliances. In particular, considering a drawing of a nail puller, we have an active force acting on the nail puller, and then we mentally remove all the constraints. In other words, we mentally pull out the nail and the support surface, and thus we have a system of three forces, which lines of action lie in one common plane. Analyzing various machines, in view of their symmetry, we can draw them in a plane, and considering the active force, in other words, the weight of excavator and the reactions of constraints such as the support surface, we shall also have a coplanar force system. From the basic theorem of statics, we know that the necessary and sufficient condition for the equilibrium of a rigid body under the action of an arbitrary force system is that the principal vector and the principal moment of the force system be zero. As we consider the case of equilibrium of a rigid body under a coplanar force system, the principal moment is an algebraic value equal to the sum of moments of all the forces with respect to a chosen center. And the principal vector is represented with its two projections. The projection on the axis x equal to the sum of projections of all forces on the axis x, and the projection on the axis y equal to the sum of projections of all forces on the axis y.